Exercise 6.2, Problem 11, Discussion. A boy is designing a diamond-shaped kite as shown in the figure, where AE equal to 16 cm and EC equal to 81 cm. He wants to use a straight crossbar BD. How long it should be? Okay, so this is a kite, and this is given as AE is 16 cm and EC is 81 centimeter. Okay, it's given 81 EC, and he wants to use a straight crossbar, that is this bar BD, and we are asked to find the length of this. Okay, so how will we do this? Now you got to see that these two sides are equal, okay, and these two sides are equal, and this is right angle, this is right angle, this is right angle. So now look at this ED. ED is a line drawn from the vertex of this right angle. This is a right angle triangle, right? ADC. This is a line drawn from the vertex, a perpendicular drawn, a line drawn from the vertex of a right angle, and it is perpendicular to the hypotenuse. In such a case, this line AD divides the original right triangle, the original triangle of ADE, into two similar right triangles, and it is also similar to the other one. What it means is that when this is a right angle, right? So when you draw a line from the vertex and at the same time perpendicular to this hypotenuse, right? This for this triangle ADE or ACD, this is a hypotenuse, this is a right angle. So you're drawing a line from this vertex which is perpendicular to the hypotenuse. It divides it into two right triangles, this right triangle and this right triangle. All the three, that is AED, is similar to DEC, and it is similar to ACD. So all these three triangles, 1, 2 and the original bigger triangle, are all similar to each other. This is a given similarity property. Okay, so we'll have to use that to get this equation. And then there is one more property, actually, RHS theorem. Okay, I'll try to see whether RHS, right angles side, actually, if I remember correctly, it's RHS theorem, by which if you have one side on hypotenuse and a right triangle equal of both the triangles, then the two triangles are congruent. If you consider these two triangles, right triangles AED and ABE, this side is equal for both sides. AE is equal, and you see the hypotenuse AD is equal to AB, right? So one hypotenuse are equal, and one side is equal because it's a common, and both of them have a right angle, right? So this case, triangle ABE is congruent to triangle AED. It is congruent, it is not similar. Congruent means all the sides are equal. All the sides and all the corresponding sides and the corresponding angles are equal. But whereas in similar, the angles are equal, but the sides are proportional. Okay, that's the difference between congruence and similarity. Okay. Okay, so let's mark what is given. Given is a dimension figure is given. We are asked to calculate length of the BD. As I was saying, we need to use formula or a hint, actually. Similarity triangle for right triangle property. Similarity triangle properties pertaining to right triangle, and RHS theorem will be used. Step 1, you have to carefully review the figure, then only you'll be able to get it. We know only these two sides, and we want to calculate these two sides. Okay, so which means we'll have to use the similarity triangle properties to get it. Now, first condition, we'll have to deduce or prove that these two triangles or three triangles ADE and CDE and ACD are all similar to each other. And that is what I was saying. Whenever you draw a perpendicular line from the vertex to the hypotenuse opposite to the right angle, then it divides the original right triangle into two similar triangles, and all three are similar to each other, right? Then calculate ED. So you will have to show that once that is similar triangle, using the similarity triangle property, you will be able to calculate ED. Next, after that, now you know ED, then you have to show this triangle is congruent with this angle using RHS theorem. That is, ABE is similar to AED. If it is shown, then what happens? ED will be equal to EB. Once you know ED equal to EB, then you can calculate BD, which is nothing but 2 times ED, right? Because this side is equal to this side. Then we know already this, we have already calculated earlier. So this into 2 times will be the total length. So that is how this problem will be done. So let's get into the solution, then it will become clear. Okay, so here what it means is that when a perpendicular is drawn from the vertex of a right angle triangle to its hypotenuse, then the triangle on each side of the perpendicular are similar to the whole triangle, and actually they are also similar to each other. That's what it is. So whenever you are drawing a perpendicular from the vertex of the right angle triangle to its hypotenuse, then the triangles on each side of the each side are similar to the whole triangle. If they are similar to the whole triangle, then they both are also similar. Am I right? So the triangle this is a right angle, right? For the triangle ACD, and you are drawing a line perpendicular from the vertex to its hypotenuse, right? Then this divides into two triangles, 1 and 2. So AED is similar to CDE, and that is also similar to ACD. Okay, so that is what it means by the similarity triangle property. Now let's take these two triangles, the smaller one and the bigger one. These two triangles are similar, so their the ratio of the corresponding sides will be equal. Now let's do that. Okay, we know AE is given 16 centimeter. I've missed to mark it. Similarly, EC is given 81 centimeter, and so we know these two sides. So from which we should be able to calculate this side. Now, let's take the corresponding sides for this one. Let's take this triangle AED. We'll take only the two sides which contain the right angle. The bigger side containing the right angle divided by the smaller side containing the right angle, that is ED divided by AE, will be equal to, now come to this triangle, which is a bigger side containing the right triangle, it is EC divided by ED, the smaller side. This is right angle, this is also right angle, am I right? So this is the right angle for this triangle is contained by these two sides. Which is a bigger side? EC is bigger than ED. So bigger side is EC. EC divided by ED. So that's what it says. ED divided by AE. ED bigger side divided by the smaller side containing the right angle for the triangle AED equal to, correct? Equal to CE, the bigger side containing the right angle divided by the smaller side ED for the triangle CED are both equal. So this is how you will have to find the corresponding. Actually, you have to use angles or sides to find out similar corresponding sides. It's very important. If not, you will be comparing wrong sides. So ED by AE equal to CE by ED. Now what will happen if you cross multiply? You will get ED square equal to CE into AE. But we know CE, that is CE or EC is the same, 81 centimeter, and AE we know it is 16 centimeter, right? So ED square will be 16 into 81, or ED will be equal to square root of 16 into 81. Square root of 16 is 4, and square root of 81 is 9. So 9 fours are 36 centimeter. So ED equal to 36 centimeter. Now come to these two triangles, ABE and ADE. So you can see AE is common for both the right angles, and you know hypotenuse is also equal, and it's a right triangle. If this is right angle, this is also right angle, right? Because angle of a straight line is 180 degrees. So this is 90 degrees, means this is also 90 degrees, right? So what does RHS says? Whenever you have a hypotenuse and one side of a right triangle equal, then these two triangles are congruent. So here we say this side is same, which means equal, and you know the hypotenuse is equal, and it's a right triangle. So which means these triangles ABE or AEB is congruent with AED. These two triangles are equal. So which means the sides are equal, which means BE equal to ED. That is what is the condition. So BE equal to AD because these two triangles are congruent. Got it? And we know what is ED. So BE equal to ED. So our BD will become to 2ED, right? BD is BE plus ED, but we know BE is ED. So it becomes BD equal to BE plus ED, that is equal to 2ED. So 2 into 36, that is equal to 72 centimeter. This way you can do, or you know ED is 36 centimeter. So BE is also 36 centimeter. Am I right? Because both are equal. So BD will be equal to 36 plus 36, 72 centimeter. So length of the crossbar is 72 centimeter. Okay. So I hope I've made it clear. If not, please go through it one more time. So the key is using the similarity triangle property of a right triangle. That is, whenever you draw a perpendicular from the vertex of the right angle triangle to its hypotenuse, then it divides it into two right triangles which are similar to each other. So this triangle and this triangle are similar. So using similarity triangle property, calculate ED. But while calculating, please be careful to compare only corresponding sides. So in this triangle, the corresponding sides are this and this. So these two sides contain the right angle. This is hypotenuse, right? But what we will do is that, so this side is the longer side and this is a shorter side. So ED by AE will be equal to, which is a longer side here, EC, and this is the shorter side. So ED divided by AE will be equal to EC divided by ED. And these are the two sides which contain the right triangle. That is very important. Next, you have to show this triangle and this triangle are congruent to each other. Once they are congruent, you know this equal to this. So then the total length will be the sum of these two. That is 36 plus 36, or 36 into 2. That is equal to 72 centimeter. Okay. So I hope I made it clear. If not, please go through it one more time. It will become clear. Thanks for watching this video.